To MyProjectBazaar.com. Now we discuss about the product for achieving memory access equalization via round-trip routing latency prediction in 3D many-core NoCs. Next, we see the abstract for the product. With the scaling 3D IC technology development, 3D system design is becoming the main research trend, especially network on chip as a novel option for integrated multi-core system is submerged in 3D tide. 3D NOC can make use of current 3D IC many advantages, including reduced the global wires, decreasing the end-to-end delay, lower power, increased the package density and saving chip area, supporting interconnect design with different CMOS combined in manufacturing technology. Due to the 3D NOC manufacturing technology limits and design complexity constraints, current 3D NOC research focus on simple 3D mesh topology. Ideal analysis show that the 3D mesh XYZ deadlock-free algorithm achieves the better system performance under the middle size of interconnect and typical traffic pattern. But in a larger system with increasing cores and the various specific application, traditional 3D mesh framework leads a extra more delay and reduced performance. On the other hand, the thermal has become an important performance parameter in homogeneous multi-core system based on 3D IC. Layered IP in vertical direction causes smaller footprint and serious contact heat and local temperature, and peak increases badly. Therefore, the exploring the different methods of IP4 plan for the performance and temperature distribution of indispensable topic of for 3D NOC. From the above analysis, this paper choose the torus topology with a shorter interconnection radius and study in for 3D external topology and the deadlock for free routing algorithm to break through 3D mesh performance fault. In addition, distributed shared memory in homogeneous multi-core system and realistic multi-phase through thread application are used in practical and experiments. Moreover, the thermal IP4 planning influences on multi-core system are considered respectively. 3D IC technology drives network on chip design on towards 3D trend and relevant multi-core system further development. However, the most recent researchers still focus on the fundamental 3D mesh structure and have no conventional traffic pattern modes in realistic application. In this paper, we present the complete design framework of a distributed shared memory homogeneous multi-core system based 3D torus interconnections. A gray code routing mechanism is also proposed to solve the deadlock. In addition to we evaluate the 3D torus system and with both systolic traffic, uniform and transpose pattern and real parallel multi-thread benchmark comparing with 3D mesh. Our experimental results demonstrated a significant reduction in the average packet latency and high throughput, as well as the major improvement execution cycle in typical thermal aware IP mapping methods in 3D torus multi-core systems. Next, we see the flow diagram for the product. This is the flow diagram for 3D NOC architecture design. This is the source router input data bits to apply the first layer mesh topology based NOC architecture design. This design consists of 4x4 router architecture. Each router consists of some components: master internal, master external, slave memories and network interface, and the switching function. These function to be separate for the single router architecture design, and these architecture same as the 4x4 router architecture. These router to be consist of the 16 router present in the one layer. The 3D torus based network 3 layer to be considered. Totally 48 nodes are present, 48 router nodes are presented in the 3D structure. Then to apply the repub reroute algorithm for based on the internal collection. These internal connection to increase the performance for neighbor estimation process, and to check the neighbor estimation router, then the neighbor estimation router to calculate the weighted calculation. The weighted calculation based on the gray code algorithm. The gray code algorithm, each and every weight represent the each and every router internal position, and to calculate the minimum router for nearest neighbor nodes, and to analyze the minimum weight values and to check the minimum weight value. If the minimum weight value is minimum, to satisfy the yes condition. If the minimum weight is maximum, to be no condition, to another check nodes for the process to be created in another one time. Then the neighbor router estimation process based on the our report readout algorithm and the gray code algorithm. And finally we analysis the final destination for 3 layers, and these process to effectively identify the shortest path identification for overall 3D based NOC architecture design. This 3D NOC architecture design mainly do in the DHTL language, and this software to represent each and every structuring level and to analyze all the things and to identify the shortest path for overall 3-layer based NOC architecture design. This is our the final flow diagram for the overall product. Next we see the final output for the product. Our process was doing the Xilinx 14.2 software. Then this is our the program for the overall 3D based NOC architecture design. This is our the simulation process. Then to select the simulation and to select simulate behavior model and to double click the simulate behavior modeling section. This section after behavior model completed successfully to create the iSIM project navigator. This navigator is used to simulate the overall processing level. This is our the simulation window for our required input output architecture designs. This is our the reset signal to be set the reset function initially 1 and to apply the 8-bit input data bits for transmission process. This are the enable write functions for our required output architecture. This set the run, then to run. Then to apply the key functions and to generate the final output data bits for overall architecture. This are the transmission based process for required final output data bits. This is the final data bit for required architecture. This is the overall data bits to be presented. This is the shortest path identification for path 0 and path 1, path 3 and the path 19 and the path 22 based on our the weighted input section, and the path 23, 22 and finally 26, and finally we have 31 path. This is our the overall final structure for the our shortest path identification of present 3D based NOC architecture design. This is our the simulation output for the overall NOC architecture design. Then we go to the implementation based process. The implementation process to identify the RTL diagram. The RTL diagram to represents the what are the logical block presented in our 3D based NOC architecture design. This is our the required logical diagram for the 3D NOC architecture design. Then we go to the technological diagram. The technological diagram to represent the FPGA structure method designs oriented based process. These are the lookup table and flip-flop pairs and input output and the buffer element connections for our required 3D NOC architecture design. Then we go to the report for the synthesis report analysis for the overall device utilization summary and the timing summary for overall output based process. These are the timing summary and the frequency, speed, latency time and the minimum period for overall NOC architecture design. These are the overall process for our required 3D based NOC architecture design.